great to have you here. Thank you very much, everybody, for jumping on. And so today we got a good one. We've got how to architect the best remote monitoring system for optimal data acquisition. And I'm honored to be here with Taylor Cooper from MistyWest, Brian Cerchio from Losant, and Cyril from Actility. So let's go ahead and get this thing started off. I'll give some brief introductions, and then we can jump right in. So Taylor, we've worked with you, or I've worked with you off and on over the past couple of years, and at MistyWest, you're the principal engineer there. MistyWest is a full product development firm focused on hardware and data acquisition. Brian Cerchio is a member of Losant, and Losant is an enterprise application development platform focused on all kinds of applications, including smart environment, condition-based maintenance, asset tracking, logistics. I'm excited to talk to you about application development. And then we have Actility and Cyril. Actility is it's a LoRa Alliance member, really focused on connectivity between actual hardware devices and the cloud. So maybe just to get started, I'd really like to introduce or have you talk a little bit more about your roles and your background. So let's start on the hardware side. And Taylor, thank you for jumping on. Can you tell us a little bit about yourself and MistyWest?
Hey, thanks for having me, Danny. Let me just check and see if I have the right microphone.
As this is going on, let's go ahead and start with Brian, actually, with Losant.
Great. So hopefully we don't have any feedback here, but my name is Brian Cerchio. I manage the enterprise solutions team at Losant, primarily focused on implementation of solutions, utilizing Losant's application enablement platform as a great backup services layer and business logic to help us get applications developed and off the ground for our customers in a quick to market fashion. My team specializes in building applications that are a little more complex for their, basically, we build solutions that leverage the power of our platform and develop a front-end interface to really deliver a branded solution for our customers and also our customers' customers.
Thank you. And you've actually had quite a long history in application development and connecting IoT products to what? Can you tell a little bit about your history as well?
Yeah. So prior to being with Losant, I worked at a company called Everything But the House. I was the director of IT there. And one of our biggest challenges was our focus was on estate sales, and every item was a unique SKU. So really figuring out how to track and understand where these items are were very important. When you have 70,000 plus pieces of inventory that are all unique, you can't lose those at any point. So they're all critical assets. So my history in critical asset tracking goes back quite a few years, and that really was what brought me to Losant. Was using that experience of the struggles that we went through trying to develop solutions that were really complex and difficult to build. Finding Losant was a great way to help us, or was really a great way to help build those solutions and leverage the expertise of other IoT experts to get these solutions off the ground.
Thank you. Thank you very much. And so, Cyril, can you tell us a little bit about Actility and then your background? If I remember correctly, it's been around 4 years with the company now?
Yes. So, I joined Actility 4 years ago. Today, I'm working for Actility as a sales manager for the Americas region. But I joined Actility 4 years ago as a project manager, delivering Actility solution to key account in Europe and here in the US. And then more recently, I have transitioned to this sales position where I focus in finding new partners for Actility and also new solution providers.
And can you provide some clarity on what Lorawan, long-range radio network, and talk a little bit about that and how Actility is involved?
Yes, so the Lorawan technology, it's what we call the long-range, low-power network technology. By long range, usually we refer to 5-10 miles around radius around the gateways, and by low power by like 25 milliwatts. So you have a similar coverage or even better than a cellular network, but using very little power. So with the Lorawan technology, you can address use cases where you need battery-powered devices. And because it's really low power, you can run those devices for sometimes 5-10 years. And then the Lorawan technology, it's actually a standard. There is the LoRa Alliance is the entity that is doing the specification of this standard. Actility is a founding member of this alliance with Semtech. And to give you a few numbers about Lorawan, today there are more than 100 million devices deployed into the field. Regarding the LoRa Alliance, we have an ecosystem of 500 companies. And at Actility, so we leverage this LoRawan technology to provide IoT connectivity platform to our customer. And today our main customer are the big telecom operator in Europe, such as Orange, KPN, Swisscom. We also work with NTT and SoftBank in Asia. And here in the US, we work with the main cable operator. But I want to mention that we don't work only with the big service provider. We also work with companies such as Volvo for asset tracking. We work with solution providers such as Birds in France that are doing water metering, and also with system integrator such as Cisco, who is, by the way, an investor of Actility.
All right. Thank you very much. Appreciate it. And then Taylor, let's do the mic check 2.0. Oh, okay. So
I haven't actually changed anything since our test run, so I'm not exactly certain.
I think
It's fine now. I'm turning down the volume on my speakers, so
Okay.
maybe I'll just do that while I'm talking. It's kind of weird. Yeah, so my name's Taylor. I'm an engineer with a background in hardware product development. I've previously worked at a medical device company, an experimental cosmology lab, and kind of all over the place, which is the weird project that I've worked on in the past. At MistyWest, I've worked here for about 6 years. I started off as an engineer, working kind of as a mechatronics engineer across a wide range of projects. And more recently, I've become a principal, and I kind of lead our larger technical teams or try to figure out partnerships or who we can help and where we can help. MistyWest as an entity is a hardware product development company. So we provide engineering services. We're a team of 25 scientists and engineers, primarily with a background in engineering physics. And primarily we help IoT projects where they need a bit more of a first principles approach. So when there's some underlying physics or some underlying problems that go beyond just raw engineering integration. Though we do work with companies like Actility and Losant, integrating their technologies into final solutions for clients.
Great. So you're starting generally on the low end of the spectrum, all the way down at the device side. And so maybe Taylor, while you're going with the microphone, can you tell me a little bit about how MistyWest approaches projects incorporating remote monitoring in general, but also in more specifically data acquisition?
Are we still going? Yeah, we are. I need to mute it. I honestly don't know what happened. How we approach projects that require remote data acquisition is very much on a case-by-case basis. As you can imagine, we work on a variety of things. Projects can be anything from, for example, right now we have a project where we're working on custom muon detector that's basically used to image kilometers of rock. So you put it down a borehole, and instead of having to drill 100 boreholes to image an ore body, you deploy a muon detector in one of these boreholes and wait a couple months. So there's some pretty complicated electronics that go into that. And we're also working on projects that are like, for example, trapping and preserving mosquitoes so that the blood in their abdomen can be put through a sequencer so that people can study the pathogens in the animals that they bite, so even humans, right? So you could use this potentially as a way to track COVID even. So again, we're providing a small piece of the puzzle to these projects, so our clients are providing the full solution, but we're kind of solving the engineering problem there. And in terms of how we approach data acquisition for problems like this, it's very much on a case-by-case basis. The first thing we'll always do is look at off-the-shelf solutions. It's always cheaper if you can find an existing solution that meets as many of your needs as possible. And often people come to us because there really just isn't an off-the-shelf solution. But we'll always start by checking for that. Then we try to answer questions around, data rate, power consumption, what kind of compute is needed. Do you need some significant edge compute? Do you want to disidentify your data before sending it over the cloud because maybe you're worried about HIPAA compliance or things like that? Because we do work a little bit in health and medical. And then obviously we're also thinking about volume and cost. So if you don't have very aggressive cost targets, often you can get away using an off-the-shelf solution like particle IO, things like that, or a more module-based solution. We also do, chip-down solutions where cost is a real driver, and we're not using a module. We're trying to do our own RF integration, FCC certification, things like that. And then in terms of the connectivity side, more and more the projects we work on are wirelessly connected, and then we're looking at what are the data rates, what is the availability, what regions are you planning on deploying it to, and then we're going to get into questions like can it be connected over Wi-Fi, can it be connected over BLE, are you building a network? Do we want to look at Lorawan as a solution there? Or are we looking at cellular? And then when you're talking about cellular, you're thinking about things like, can you use NB IoT? Is it low bandwidth enough? Is there NB IoT in your region yet? Or do you need mobility support? And then maybe if you're low bandwidth, you're looking at Cat M1 as a cellular solution. Or if you're very high bandwidth, you're looking at 3, 4, 5G solutions. So that's the
Thank you.
I guess.
Thank you very much for going into that. And like you said, there's a lot of different use cases that change what people need to look into in terms of off-the-shelf modules or getting started from scratch. And it sounds really interesting that MistyWest can really hit more of the R&D side of the spectrum versus the typical IoT use cases, monitoring temperature, movement, position, etc. So thank you very much. I think that there's a good segue. You mentioned mosquitoes and COVID-19. I'd like to actually go ahead and jump over to Brian and ask you quickly about what you're seeing with regards to COVID-19 and application development, IoT contact tracing, mobile apps versus actual IoT devices. What are you seeing in the market lately through Losant? Because I know Losant has thousands of applications in the field right now.
Yeah, so as COVID-19 has really affected all of our lives significantly, we're seeing a huge push in the market for all organizations to really focus on the health of their customers, their clients, their employees. So it's really been a huge, not even really shift, but wanting to leverage the technologies of IoT already, which are related, which is a lot of asset and location tracking. This can also be brought into the individual themselves. So really, how do you protect your customers, your clients, and your employees is such an important thing that we're seeing across the board. Companies wanting to see what's available and develop solutions to determine how to keep everybody happy and healthy, which is the most important thing. And there's a couple different parts to that. You mentioned that the mobile applications versus using an IoT solution. The mobile applications themselves are really developed for the public consumption itself. So downloading a mobile app on your phone, there's a lot of constraints there that are things that enterprise generally has struggles with. The first is how a lot of individuals don't have a corporate device that's a mobile device. So we have to talk about the privacy aspects of installing an application that does do contact and location tracking in any matter onto a personal device. As individuals are becoming much more conscious of what their data is being used for, what their privacy is, when their privacy is being invaded in any manner, it's really a challenge to make sure that contact tracing really only works if everybody has it and they have the same application, they have the same device, the same application, and everybody's got it installed. So being in enterprises don't have that mandate they can have in the general public. What they can focus on is their controlled circumstances. So while mobile applications require a much more expensive piece of hardware that's generally very individualized, IoT applications such as Bluetooth LED beacons and things like that can be distributed at a construction site, at a manufacturing facility, at a hospital upon entry, and really trace that in a much more granular manner that doesn't require as much potential personal identifiable information being shared, which is a big concern, is sharing that data, so sharing your data. So, but we still want your HR representatives to be able to trace and figure out if somebody is infected, potentially who did they infect. So solutions we're seeing out there are a lot of times a device that's given and assigned to an individual, and that person, if they come within, let's say, a case study we've recently done, within 10 feet of another person for more than 60 seconds, records that activity. That's all through Bluetooth LE tracking. And those devices aren't identifiable specifically to an individual except for the assignment, whereas a phone itself, a mobile device, will have that, and you're going to persist that data, that information about what that unique identifier is in the phone. So it allows a little more privacy, but also the devices are more cost effective and also purpose built. So they're really developed specifically for that application. So you can even get better granularity, more information, and more traceability that enables enterprises to really capture the important information in a manner that's very effective and not burden their staff and individuals with having to use any personal information or personal data in a manner that isn't necessary for the corporation.
Thank you. So when companies are determining what they would like to use for any kind of remote data acquisition system, whether it be a phone collecting data or whether it be devices, as a follow-on question for you, Brian, is how do you generally work and help companies decide? Sometimes it's working with a company like MistyWest, who's doing some kind of really cutting-edge sensor data acquisition, and it's a new method that needs to connect up to Losant. I guess this might also be a question for you, Cyril, because I know you deal quite a bit with connectivity, actually getting the data from a hardware device to the cloud. So let's start with you, Brian. Maybe can you talk a little bit about the challenges involved there, the cooperation between hardware and then the software data, analytics that your platform provides?
Yeah. So Losant itself is designed to be a hardware agnostic platform. We have means of getting information into the system via some standard protocols, and really we're constantly adding more and more protocols to get data in. But as far as the hardware goes, we don't manufacture the hardware directly. We partner with other organizations to really figure out and build or buy the right solution. So our partnership team has built a very robust partnership network of hardware manufacturers that really go across the board, and we want to leverage what their unique skill set is. As was mentioned, like Taylor said, that if you can go off the shelf, it's always a cheaper solution. But there are some times when custom development has to happen. So we want to leverage our expertise in that requirements gathering and our experience in seeing what's in the market and help find the right partner for our customers.
Great. And then Cyril, can you talk a little bit as well? I mean, so is your network completely Lorawan based? What about devices that cannot connect to Lorawan? Or how do you help companies figure out how to get data from devices to the end application?
Yeah, so it's a LoRaWAN connectivity platform. So we are not hardware agnostic. You need to use devices, sensors that support LoRaWAN. But thankfully, there is a strong ecosystem. So for COVID-19, for example, at Actility, we have acquired a company called Abiway a few years ago. Abiway, they are designing LoRaWAN trackers. They were actually the first one to do that, and we are using those tracker. I think in a similar way than Losant is doing, with using the BLE capability of those tracker to detect another tracker to detect if someone is closer than 6 feet. And then we use the Lorawan as a transport protocol to store this information in the cloud or on a third-party application server. So we have to work on this solution. It's like it's a turnkey solution with the trackers, the connectivity platform provided by Actility, and then we have partnered with an application server for storing and seeing the data.
Okay, so you provide kind of the infrastructure backend to actually get the data from a Lorawan device to a cloud application. And this might be a business application that's already built out and just needs the data input. I recently actually saw the news that you guys are now completely certified within the AWS IoT core, and you're now in the AWS marketplace. Can you talk a little bit about the decisions that a potential company who's interested in pushing an IoT initiative has when it comes to the cloud side, once getting the data up into the cloud, and then what do they decide?
So first we are very excited to have signed this partnership with AWS. So the work we have done now, it makes it very easy to integrate our connectivity platform with AWS IoT Core. So now it's like a one-click process to integrate our solution with AWS IoT Core. And then when you are attached to AWS IoT Core, then you have access to all the AWS service, such as the new one that is available now. It's AWS Sitewise, which is a service from Amazon that allow you to collect and store and also see data from industrial equipment. So we make it really easy to for your sensors that are deployed into the field to push data to Amazon. As I said, this integration now, it's really a one-click process. So for us, this partnership, obviously, it's bringing us a lot of visibility being on the AWS marketplace, but it's also making it, we also improve the customer experience with this integration.
Thank you. Building on that, I'd actually like to jump back to you, Taylor. How early does this conversation go? Do you often talk to clients and enterprises who are starting from the ground up? Hey, I need to collect this data. Can you help me do that? Do you talk to them about what they're going to do with the data, how they're going to get it to where it needs to go? What kind of guidance does MistyWest provide there, and what kind of services does MistyWest provide?
Yeah, is this a little better? Still getting echo?
I think if you just turn your speakers down, that should work for now.
Yeah, I've done that. It's automatically adjusting the gain on the microphone. Anyway, I'm going to mute the speakers and I'll talk to that.
Technical problems.
Yeah, it's so weird because none of this was happening in the desktop.
Yeah.
Okay, so I've muted the speakers. Yeah, in terms of how early we get involved, honestly, as early as napkin sketch sometimes. Though usually when it's a napkin sketch, we'll do things like back of the envelope calculations to go with your napkin sketch, just to check for feasibility and things like that. We'll do usually like a 1 or 2 day ideation session where we'll just try to answer, is this feasible? Are there some things we already know about that might make this easier or harder, or potentially sometimes impossible? So we do get involved at the very early stage, where rubber starts to meet the road, where our value proposition really starts to get going, is kind of when you have those high-level engineering requirements, that high-level need. We can help turn that into a detailed set of requirements that is like an actionable project where you can put a team of engineers on it and achieve results. So we get involved at the pretty early stage. I would say probably before Actility, it's like kind of before the decision for say Lorawan would be made. And we might provide guidance around, say, different wireless solutions or what the implications of those are in terms of, the cost structure for your product or your solution going forward, and help you kind of stitch that together with what your client actually needs. Hopefully that answers your question, but I could dive into lots more detail, but I'll maybe leave it there for now.
No, I think that's great. Just wanted to get a sense on if I'm looking to start an IoT initiative, how early do I need to look at the software side of things versus the hardware side of things? What is better to look at first, even? And I guess I'll turn this into another question for the whole group. Kind of what are you seeing in industries right now? What industries are pushing the boundaries in remote monitoring, data collection, and which industries are have you not been seeing much work on?
Well, I can kick it off. So what we're seeing is that across the board, as IoT, it has such a breadth of value. Even traditional businesses and traditional industry really are starting to understand what can be brought to the table by IoT. So it kind of amazes me every day what our potential clients and partners are looking at to try and solve problems. How we kind of value ourselves is coming in from that early stage, just like Taylor had mentioned, as being that first partner to talk about, well, what's the problem, and finding out what the core issue is, and how can we determine that across the board is this a solution that IoT can solve. So even from traditional businesses such as manufacturing, that they're really interested in being proactive in solutions, which IoT allows you to do. Where traditionally it has always been, a very reactive, preventative maintenance was a scheduled thing where every 6 months I come out and look at a device or anything like that. Companies now are realizing that they need to be there before it breaks or understand why it's breaking, and add that as a value add to differentiate themselves in the market. So as companies are competing for traditionally manufactured items, that's where our condition-based maintenance stuff really comes to play. Is how do you differentiate with your service package that you can offer as a value add to your customers? So say you buy a ton of hardware, how do we make sure that hardware either never goes down, or if it starts going down, we know why and can be actionable about that? So the big focus of what we look at Losant is providing data in an actionable and visual way. So it's just really adding value to the end user and customer as across the board we're seeing. So it's really, most industries, the market drivers and the ones that really want to be ready for the next generation are pushing towards that.
Okay, so I kind of got from there that you're seeing a lot of OEMs, original equipment manufacturers, companies that are actually manufacturing hardware products. They're really putting the effort into connecting their products up, monitoring their products, sort of in the same way that we do in the software world, where you'd never dream of pushing up a website, for instance, or an application without the ability to change it in the future. That you're seeing that on the hardware side. People who are developing physical products will change it in the future and monitor how it's being used.
Yep, that active monitoring, alerting, and OEMs are a great example of an industry that's a traditional business that really is embracing IoT.
Great. Anything from the Lorawan side, Cyril? Where you see?
Yeah, I would say, like, on our side, what we see is that the company or the IoT that are like pushing the boundaries are the one with a strong return on investment, like company or use cases where you have a direct return on investment are the ones that are successful today. In the Lorawan world, I'm thinking about waste management. When you add the capability of sensing the field level of a trash container, and then from that information you can optimize the trash collect. This is a use case that generates a lot of savings, important savings for a city. So that are very successful use cases. Another use cases that we see in the Lorawan world is in smart buildings, water leak detection. This use case also has a strong return on investment because you reduce the insurance fees, and you are also the promise that if there is any leak, the water damages will be less or reduced.
Okay, this is bringing up an interesting question just about how Actility is actually implemented in an actual project. Let's say that MistyWest designs a new water sensor for building commercial purposes. How does Actility get involved? Let's say it's a Lorawan device, the radio that MistyWest has incorporated into the sensor. They've got thousands of them now that they're looking to deploy across a city like Chicago, for instance. Do they then directly work with Actility, and Actility handles all the gateways and all the network that needs to be built up to work, or how does it work?
That's the hard part, I would say, with every IoT project is there is several parties involved. You have on one side the devices, the sensors, the connectivity, and on the left side you will have the business application. And at Actility, it's a 10 years company. As I said, being the founding member of the LoRa Alliance, we know the ins and outs of this ecosystem. So when there is such an opportunity, we try to bring everyone on board because at Actility, we are here to provide the connectivity. We are not developing business applications. So we have to work with partner for the business application and with partner for the hardware side.
So in this exact example, we're doing water management in buildings. We have thousands of devices. MistyWest has helped a company develop this end device. How would you support them in getting their devices implemented across the city? You'd help them find a gateway provider then, or help them network?
Yeah. So at Actility, we provide the connectivity platform, the back end of the connectivity platform. Lorawan, it's a cellular network, so you need a gateway on the field. It's not a mesh network, you need gateways. We work with gateway manufacturers, the main gateway manufacturers available today, Actility, Multitech, Curlink, but also UfiSpace or Gentech. So we have integrated all those main gateway manufacturers. So we are able to resell those gateways. We work with the device manufacturer for the hardware side, and then also we have partner with different like application server provider for these use cases. We have several partners to help to integrate the opportunity.
So I guess on the application development side, how often does Losant come in just for the application development versus earlier on, you said it's hardware agnostic, which means you're working with hardware devices, sending data up to the cloud. When does Losant come in? And you said that your role specifically was actually to manage these custom software application development initiatives that companies can't do on the Losant platform.
Yeah, so I'll go a little more in depth on that. So it really varies depending on the customer itself. Losant, the platform, the application enablement platform, is frequently purchased by about half of our customers to do development themselves. So they may have the in-house resources and engineering teams to kind of build this themselves and help source the equipment. So that's a large portion of our customer base is buying the platform as a SaaS model to utilize the simplicity and power of developing applications in a low to no code environment, but also with the power to be able to really inject some development resources into it as well. My team comes in to help build those applications that require what we call as experiences. So custom experiences to brand and make sure that it's developed in a little more complex manner. Now, some of our customers that are looking for us to just come in and do the front-end application development and the back-end development for the business logic. Others want us to be and are looking for a real partner in developing the solution. At that point, we would start reaching out to our partnership network, such as Actility, MistyWest, companies like that to help break down the connectivity layer and all the way to the device. When I think about IoT engineering, I kind of think of it like the full stack of engineering, where it's all the way down to hardware and firmware development, sensing devices, connectivity gateways through data transmission, databases, data science analytics, and application development. I mean, there's just so much breadth where I try and think of the best way to approach a problem is to focus on what your business is core, unique, and really good at and provide that value versus trying to reinvent the wheel let's bring in partners that are great at their field, and we'll work with them to really build the best solution for our customers. It's like I would never go and try and build a compressor. I'd leverage a company that builds a great compressor. We'll instead, give value to to giving a business application on top of that.
Thank you for breaking that down. It's really cool to see, and I completely agree with you that it really there's a huge mesh of different parties involved and needs to cooperate and collaborate and build upon what's already been built. And we're at a cool time right now where this is possible. So I'd like to jump back in, and also for anyone watching, feel free to ask any questions in the window. We'll hit those up, and we can either bring you up on stage or I can ask them directly. But one more question for you, Taylor. I'm very curious to hear and see kind of the types of things you're seeing, because you already brought up some very cool applications that I haven't heard before. And what are the kinds of crazy sensor applications that you're working on, or are you seeing in the market?
Yeah. Well, I just don't want you guys to get feedback here. Yeah, lots to say there. We're definitely seeing, and I think it was kind of about trends as well, but I'm going to maybe talk about just two specific applications again, just so it's a little more tangible in terms of what we're seeing. When I first started at MistyWest around 5.5 years ago, one of the technologies we worked on was an optical particle counter technology, which is basically a way to measure particulate matter in the air. There's kind of two ways to do it. One of them is called mass concentration, where in theory you pump a bunch of air through a filter and measure how much mass ends up on it, how much dust ends up on it. And another one is particle sensing or sizing, where in this case we built a custom sensor where you pass air through a laser beam and it causes light to scatter off of particles in the air. And based on a photodiode that's measuring that scattered light, you can guess what the particulate load is in the air. So these are kind of like two different ways to measure air quality. And there's a lot of science now that is getting stronger and stronger. And there's more and more evidence now that basically maps the impact of air quality to your health. So the reason I'm bringing this up is because 6 years ago, or 5.5 years ago, we had to develop something custom and miniaturize it. We had to reverse engineer some existing technology and miniaturize it to meet the customer's need. And now I think we did a blog post about this a year and a half ago. Sensirion has released their sensing company as well. They actually build sensing solutions, sensing modules. So we do custom. They have a product line you can buy from. They have what's called the part number is the SPS 30, and it basically does the same thing, just better and cheaper. So some of these things which previously were maybe not even understood as well as health issues, but also weren't easily measurable. Like you had to go do a bunch of custom engineering and design your own sensor to even enter the marketplace. Now you can go to these places and buy modules to do it. So that's a place where I would say the industry is growing really quickly. And then the counterpoint to that is another project we're working on, which is actually in animal tracking. So this is also on our webpage. But maybe the background here is, I don't know if anybody heard about that recent paper from the University of Toronto. They were talking about how polar bears are going to be gone as a species by the start of the 22nd century if we continue on our current trends with global warming. So pretty concerning. Dialing this back about 2 years ago, we got approached by WWF to help modernize their polar bear trackers, which the last update, the last significant design changes, the original collar was designed in the 1970s. So it uses the Argus satellite network, which is still a good satellite network to use, but the collars have a bunch of problems with them. So obviously they've been a little slow to address this, but they're kind of now coming around, and that's where we're helping out. Maybe just a little more context, the problems with the collars, they fall off really quickly. You can't actually put them on the male bears because their neck is wider than their head, so it just slides right off. So you can only put them on the females. It costs like $40K or something to go out there in a helicopter, tranquilize a bear, and then put the collar on. So when a collar falls off, it's a bit of a problem. So what we're working on right now is using modern electronics. Like we don't have to stay with electronics from the 1970s, and miniaturizing it and getting it basically into an ear-mounted solution is the idea. So it's like an ear tag basically, but it talks to a satellite. So that's an example where they've been a lot slower, I think. And WWF, there's a good reason why they've been slower. They The economic incentives there are just a little different. Polar bears don't pay to have themselves tagged. You need government grants and things like that, so it goes a little slower. But yeah.
Thank you. Okay, so I have a couple more questions. One for the whole group. What are some common limitations you're seeing when it comes to data collection and ingestion for IoT applications? I guess, taking the example of an enterprise that's looking to start an initiative from scratch. And I do understand that many of these applications are very case dependent and use case dependent, but what are some things that you feel people miss or should keep in mind as they're getting started?
I can start. Lorawan, it was designed for battery-powered devices, and something that you need to have in mind when you deploy such devices is, if you want your IoT solution to run longer, you have to think about how many times you want to collect data, and sometimes it's something you need to think about. When you configure your device, if you can wait for a report, like every hour instead of every minute, you're gonna increase the battery life of your device, and then you will have your IoT solution that will run longer, and it will also save you the trouble of sending resources on the ground to charge the battery or even change the battery. So that's something to have in mind when regarding data collection, like how many time you need data, especially when you use battery.
And I mean, that application batteries come up all over the place. I can imagine Taylor has some things to say about that as well. But also, what are you seeing, Brian? What common problems with these initiatives?
So really, to piggyback on Cyril's concerns there, it's similar to battery life being affected by polling rate and the sensors themselves, but also polling rate of sending the data to the cloud. That data costs bandwidth either via a cellular mechanism or even data going into a cloud-based data center. That bandwidth coming in and out does cost money. So determining what's the effective polling rate and when data is valuable or not. When you architect the solutions, thinking about maybe edge devices where if we can batch that information and send it up in a single package, we're going to use less cellular bandwidth. We can do some processing on the device itself to really cut down on that transmission to be effective. And when you're talking about thousands and hundreds of thousands of devices, that becomes a pretty major problem of limiting bandwidth to what's really necessary versus we're going to pull every 3 seconds of every device with all of the data we have on that. That becomes very expensive very quick, and really thinking about what's the value of the data we're sending and how frequently would we need to see that.
Thank you. And Taylor?
Yeah, I'm actually going to continue that trend. So maybe these also fit nicely together. I'm going to talk more about the hardware side because I basically have the same point to make. I think, and I'll try and talk a little bit about a specific project here too. When people want to do low power, the details in the hardware often get overlooked. So polling rate is absolutely one thing you need to be very careful with, because actually having that wireless connection is expensive in terms of battery life. But even below that, there's a bunch of considerations that need to go into the hardware to get it right. So actually designing your firmware so that you don't have a bunch of things running that are not needed, and so that you're actually properly using, the low power functionality of the associated ICs on your solution. And a lot of that gets into some detailed engineering that you can't always do without getting down to the real nuts and bolts of it. So like if you want to buy a SOM, for example, our system on a module, it's going to come, with certain pull-up resistors and things like that on it already. And, if they decide to go with like a 10 kilo ohm pull-up, maybe you have on a 3v3 bus, you're going to have milliamps of current going through that thing. So you can't get rid of that if that's designed straight into the hardware. So what this often means, and where we often get involved, or where there's kind of more work to do, and in this case I'm going to talk about one project we did where we took an actigraphy monitor or a sleep monitor. It's wrist worn. It was actually worn by the Chicago Cubs when they won the World Series. It's by a company called Fatigue Science. You can find them on our website as well. We took the original engineering for that band and extended the battery life from like 1 week to 45 days. And we did that by looking very carefully at the electronics. And, you know, instead of using a 10K pull-up, like, can we get away with a mega ohm? Like, can we use microamps here? So changing the hardware, but also a lot of optimization in the firmware. So like polling rate in terms of how often they got that data, they were actually pulling that data like once a day. But the actigraphy data needs to be measured like every 10 seconds or something like that. So the IMU is continuously on this thing, or almost continuously on. It's constantly turning on, measuring, turning off. And so you have to log all of that and measure all of that and do that in a low power way, in addition to reducing your polling rate if you want to have true low power and have a device that, you know, really meets your customer need, where you can just deploy this thing for 45 days and then and not worry about the battery life. And that was with the rechargeable battery. You can go a little further if you do something that's disposable. But yeah, a lot of the new IoT applications rely on like a 10-year battery life or something like that, where you deploy something in your house and just forget about it. You know, you want to have a leak monitor, stick it behind a wall with a battery, forget about it. Getting there requires a lot of detailed thought on the hardware side that often gets missed.
And I bet you that also plays into a customer's decision to go off the shelf versus customize a solution. And that's, you know, you guys mentioned this in the beginning, is that these devices are complicated, and a lot of work goes into creating a device that's optimized for power or for transport or for analytics. So thank you very much, and I appreciate your time here today. I think we've covered quite a bit with regards to architecture of these devices, hardware, connectivity, analytics, and I'm excited. I'm excited that you're all here to talk to us. And apologies for my dog. I'm also excited to get back to the office soon. So thank you very much. And if there's any questions, please feel free to reach out to MistyWest, Actility, or Losant. We have you can come to this recording anytime, and your websites and your contact information are attached here. So again, thank you. Please be safe, and I'm looking forward to helping push more initiatives.
Thank you.
Have a good one.
Bye.
Time.